Okay, our journey through equations is progressing well at the moment, and our toolbox is expanding. Today I want to expand it one more time. Last time we looked at equations with just a single fraction. I want to look at what happens when we have more than one fraction in our equation. And it's going to take us back a little bit, back to when we were in Year 7 and we studied the concept of the lowest common multiple. And we took two numbers, and we take two numbers like, let's say 3 and 8, and we'd have to work out the lowest common multiple. And so back in Year 7 we might have had to actually list them down, the multiples of 3. So it'd be 3, 6, 9, 12, 15, 18, 21, 24 and so on. And with 8 we'd list those multiples down as well, and we'd go 8, 16, 24, 32 and so on. And then we'd look across our list for the numbers that they had in common, and we'd see that 24 was in fact the common multiple. And so that's one way of doing it. Maybe by now you're comfortable with numbers by now, and you'll be able to quickly see the lowest common multiple of 3 and 8. Be careful of falling into the trap to think that 3 8 is 24, that's always going to be the lowest common multiple. It's not always the case. So if we took, for instance, 6 and 8, and we're looking for the lowest common multiple of 6 and 8, 6 8s are 48. But if we have a look at our multiples of 6, 6, 12, 18, 24. Look at that, there's 24 along with 8. So we don't just have to multiply these two together. We can get a smaller lowest common, but the lowest common multiple is what we're really after, and that'll save us some work. And I'll just have a look at how we'd use that lowest common multiple. So we'd use it when we have an example, as I said, with more than one fraction. So if we have something like x over 3 plus 4 is equal to x over 8. And we're looking at that equation and thinking, first thing I want to do in this equation is get rid of the denominators. As much as fractions are our friends, we like to get rid of the denominators first. To do that, I have to multiply each term by the lowest common multiple of 3 and 8, 24. So I'm going to multiply every single term here by 24. So 24 times this, 24 times this, and 24 times this. 1, 2, 3 terms, 3 lots of multiplication by 24. I'm maintaining the balance in my equation that way. So 24 divided by 3 is 8. I get 8x plus 96 is equal to 24 divided by 8 is 3, so 3x. And so by now we should be quite comfortable with these type of equations, pronumerals on both sides. Normally I'd say bring the smallest to the largest, but because this has just got one number, no other numbers, I'm actually going to go minus 8x and minus 8x. I get 96 is equal to negative 5x. Luckily we're not afraid of negatives. We'll just look at that and say it's negative 5 times x. So I'm going to divide by negative 5. When I get that far through it, I'm going to say, well, that goes in there 19 times. So I'm going to reverse it, put x over here. Negative 19 and 1/5 would be my answer. Alright, so this time we want to solve this equation. So with this equation, again, 4 and 6, we need to think, what's the lowest common multiple of 4 and 6? So you mentally go through your 4 times tables, 4, 8, 12. At that point, hopefully you've worked out 6 goes into 12 as well. So I'm going to times everything by this lowest common multiple of 12. Times this term by 12, times this term by 12, times this term by 12. Remembering this is one term, this vinculum is acting like a set of grouping symbols, and I'll put the grouping symbols around it to make my life easier, and it'll remind me when I multiply by 12 it's the whole term I'm multiplying by 12. 4 goes into 12 3 times. 3, the grouping symbols there now, x minus 1. 6 goes into 12 2 times, and I start with the x plus 2. And 4 12s are 48. So I've simplified these ones down to these numbers, keeping the grouping symbol there that I've actually put in to make my life easier. So I'll get 3x minus 3 plus 2x plus 4 is equal to 48. Now this is one of those cases where I don't have to subtract everything at once. What I need to do is I need to look at this side. It's only on one side of the equal sign. It's just an expression that needs to be simplified. 5x plus 1 is equal to 48. And now it's just a two-step equation. Subtract the 1, divide by the 5.